All right, we're gonna start with homework number 24. And today we're gonna talk about natural logarithms. All right, and we've talked about logarithms in the last lesson, and this one we're going to continue talking about logarithms in the first few problems, and then get to something called natural logarithms and talk about Euler's number. But first, I want to go through the first three problems, which are a continuation of the last lesson, and continue to talk about exponential and logarithmic equations. Okay, so number one, we have 2 to the power of x equals 3. And the directions tell me to solve each equation, round to the nearest thousandth. Check your answers. Okay, so in this case right here, I have 2 to the what power equals 3. And the way that I can rewrite this is I can say log 2 of 3 equals x. All right, and the reason I would write that is because I want to find what x is equal to in the end, right? I want to isolate x. And by making this step, I have isolated x. And now what I can do is I can use the change of base formula and say log 3 over log 2 equals x. And if I were to simplify log 3, I'll go ahead and put this in my calculator, log 3 divided by log 2, and I get 1.58. It tells me to round to the nearest thousandth, so the nearest hundredth place, so 1.58. This can be my answer. So, 1.58 is equal to x. I can flip it around. X equals 1.58. There you go. And that's number one. Number two, I have 4 to the power of x equals 19. And if I'm able to write that in logarithmic form, I can say the log 4 of 19 equals x. I can use the change of base formula, say log 19 over log 4. If I put in my calculator, I can say log 19 divided by log 4 equals 2.12, and then this out 3963. I'm gonna go ahead and stop there, and let me go ahead and just do this 2.12 equals x, and I can flip that around and say x equals 2.12. All right, that was number 2. Moving on, I can go ahead and make the background of my screen that color, and we'll move on to number 3. All right, number 3, I have 8 plus 10 to the power of x equals 1008. So before I even get started here, I can subtract 8 from each side, and I get 10x equals 1000. Now I can write my logarithm here. I can say log 10 of 1000 equals x. I can use my change of base formula and say log of 1000 over log 10 equals x. If I type that in my calculator, log 1000 divided by log 10, I get 3. So I can say x is equal to 3. And you could have obviously stopped right here if you would have known 10 to the what power is x. Well, 10 to the third power is x, so I could have just done that, but I just want to continue the same trend as the last few examples. All right. Moving on to number 4. Number 4 says, write each expression as a single natural logarithm. And now I have this thing, and it shows there's this ln there. What is an ln? Well, ln is the same exact thing as log of e. And e represents Euler's number. And in the homework, I listed Euler's number. It's 2.71828182845. And it's just this really long number, kind of like pi. That's irrational and just goes on forever. Euler's number actually appears throughout nature and appears throughout the real human world very often the same way that pi does. So we're looking at compound interest, or we're looking at odds of winning certain things. Typically, Euler's number can be found all throughout God's creation. And it's very fascinating. If you want to learn more about Euler's number, it's not necessary, but I included a link in the homework file. Right? But whenever you see ln, this is a shortcut because it's used so often, they create a shortcut for it. And even if you look at your calculator, on my calculator, ln is the button right before log, because it appears so much, right? So, I mean, in the problem, number 4, it says 3 ln 5, right? That's really just log e, but it's a shortcut of writing it. So the directions ask me to write an expression as a single logarithm, so I can write that as ln 5 to the third power, just like in the last lesson, and saying ln 5 to the third power, 5 times 5 is 125. So let's raise that 5 to the third power, which is 125. Okay, 5 times 5 is 25, times 5 is 125. And that would be my answer. I can just leave that in there as number 4. Okay, number 5. Number 5, I have ln of 9 plus ln of 2. Just the same exact thing as we did with logarithms before. When we're adding numbers together, we can just multiply them, right? So my answer would be ln of 18. Okay, number 6. Number 6, I have ln 24 minus ln 6. That's the same thing as writing it as ln of 24 divided by ln of 6. 24 divided by 6 is 4, so my answer is ln of 4. That was number 6. Okay, we'll go ahead and open up a new page here for the next problem. All right, so that was number 6. We're going to move on to number 7 here. Number 7 says solve each equation and check your answers. Okay, so I have ln of 3x equals 6. So the way that I can solve this problem, believe it or not, since I have, it could be written as like log e 3x equals 6. I could write it like that. Remember that I could go ahead and just write e to the power of log e to 3 to the 6. That cancels out. If I were to do that to both sides like that, that cancels out all of this. Okay, it cancels all of that out. So if I write this problem, right, if I say ln of 3x equals 6, and I just do from one side and do the same exact thing to the other, right, where I write it as e to the 6th power and e to the power of ln 3 to the 6, these actually cancel out. And that leaves me with 3x equals e to the 6th power. And then if I divide by 3 on each side, I get x equals e to the 6, e to the 6 over 3. And that is my answer. So in the same way that if you were to have like pi over 3 is your answer, you would just leave it there. In this case, e is an irrational number. You're just going to leave it like that and say x equals e to the 6 over 3. All right? Doesn't make sense? All right, let's continue. And you'll continue to use this. Okay? ln of x is equal to negative 2. Okay? I could rewrite this as so number 8, e to the power of ln of x equals e to the power of negative 2. Okay, so I could write this as x equals e to the power of negative 2. Now, if you remember from the beginning of the year, we don't like negative exponents. Whenever we have a negative exponent, we can just flip it. And I can rewrite this as 1 over e squared. We talked about that in the beginning of the year. If I had like x to the negative second power, that's the same exact thing as 1 over x squared. You can write it like that. So that's why I took e to the negative second power and just rewrote it as y over e squared. 1 over e squared. And that's my answer for number 8. All right, number 9, pretty similar here. I have ln of x minus 1 over 2 equals 4. Okay? Once again, I have that ln, so I can just say e to the power of that and e to the power of that on the right side. Those cancel out, so I get x minus 1 over 2 equals e to the 4th power. I'm going to multiply each side by 2 to get rid of that 2 on the bottom. And that gives me x minus 1 equals 2 times e to the 4th. Right? And I guess maybe this goes without saying that is e to the 4th times, and it's just like a normal size 2, not an exponent. Okay? And then I'm going to add 1 here on each side, and my answer is x equals 2e to the 4th plus 1. And I can't add those together because these are not like terms, so I can't add them together. So that's as far as I can go, and that's my answer. That's number 9. All right, just a few more, 3 more problems, and we're all done. All right, 3 more problems. Okay, I have number 10. I have e to the power of x equals 18, and the directions ask me to use natural logarithms to solve each equation. Okay, so in the same way in the last few problems, when I had like, I don't know, ln of x equals 2, I wrote like an e down there and solved it. I can get rid of that e there and get x by itself by just writing ln on both sides, because these cancel out, and I get x equals ln of 18. And then that would be my answer. And if I were to actually type in ln of 18, I get like it equals 2.89 something. Okay, but you can leave it like that, ln of 18. I'm okay with that, at least for these last few problems here. All right, I have e to the power of 2x equals 12. I can just find ln of each side here. So I'll say ln of that, and I'll find ln of that. And that would give me 2x is equal to 12. I'm sorry, 2x is equal to ln of 12. Divide each side by 2, and I get x is equal to the ln of 12 divided by 2. I cannot simplify that, because if it said ln of 2, I could simplify it, but it just says ln. the same way that if I had an operation still that needed to be complete on the top and doesn't include anything on the bottom, I can't go any further than that. So number 11, x equals ln 12 over 2. All right, last one, number 12. I have e to the power of x plus 1 equals 30. Okay, what I can do is I can just find the ln of each side here, and these cancel out, which gives me x plus 1 is equal to ln of 30. Subtract 1 from each side, and this gives me x equals ln, I can't say ln of 29, ln of 30 minus 1. Okay, if there's no, right here, you notice that there's no ln. I can't do anything with it. I just gotta leave it there. And that's my answer. Okay, so maybe in number 10 here, I could have rewritten this a little better by writing like ln up there and written ln, I don't know, just like that to make it look nicer rather than writing it below. But that was number 12. And you are all completed this homework, number 24, natural logarithms.